Elon Musk just hinted that Tesla Bot Gen 3 will be radically different, not a cosmetic upgrade, not just smoother walking, a complete leap in vision systems, artificial intelligence, and neural network architecture, and if the leaks are accurate, this is the version that turns Optimus from a prototype into a real product. For years, humanoid robots have struggled with one core problem. They can move, they can follow pre-programmed instructions, but they cannot truly understand their environment like humans do. Gen 3 aims to change that. We are talking about advanced computer vision, real-time neural network inference, improved hand dexterity, faster learning through AI training models, and possibly upgraded onboard processing hardware. Tesla has already proven it can build real-world AI through its full self-driving system. Now imagine that same AI philosophy applied to a humanoid robot. Not just moving, thinking, adapting, learning from observation. In this video, we are going to break down what the Gen 3 leaks actually suggest, how the vision system may be evolving, what neural networks power the robot, and whether this finally makes Optimus viable at scale. Quick reminder before we continue: if you want realistic Tesla deep dives that focus on engineering reality instead of science fiction hype, subscribe to the channel and turn on notifications. We analyze what is technically possible. Now let us begin with the most important upgrade of all. Vision. Because if a robot cannot see properly, nothing else matters. Gen 3 vision system. From cameras to true perception. If Gen 3 is a real leap forward, it starts with vision. Because without advanced perception, a humanoid robot is just a moving machine. Gen 1 and Gen 2 relied on multi-camera arrays similar to Tesla vehicles that allowed basic object recognition and spatial awareness, but household environments are far more chaotic than roads. On a highway, objects are structured. In a kitchen, everything moves, lighting changes, objects overlap, hands block cameras. Shadows confuse depth perception. So what changed in Gen 3? Leaked technical hints suggest Tesla upgraded 3 key areas. 1. Higher dynamic range vision sensors. Gen 3 is rumored to include improved camera modules with better low light and high contrast handling. Why does this matter? Because indoor environments have extreme lighting differences, bright windows, dark cabinets, reflective surfaces. If the robot cannot adapt instantly, it misjudges depth and grip. Tesla's vehicle already handles harsh sunlight and night driving. Now that same philosophy may be adapted to close-range object manipulation. 2. Improved depth perception without Lidar. Tesla has consistently prioritized camera-based perception. There is no strong evidence Gen 3 uses bulky Lidar towers. Instead, Tesla likely refined stereo vision and neural depth estimation models. That means the robot estimates distance using advanced neural networks rather than expensive hardware sensors. For example, understanding how far a glass is from its hand, estimating how much force is needed to grab a sponge, adjusting grip mid-motion if the object slips. This is not simple image recognition. This is dynamic 3D scene reconstruction in real time. 3. Real-time neural processing upgrade. Vision is useless without fast processing, leaks suggest. Gen 3 may use an upgraded onboard AI compute unit derived from Tesla's self-driving architecture. Why is that important? Because a humanoid robot does not just detect objects. It predicts outcomes. If I move my hand here, will I knock over that cup? If I bend down, will I collide with the counter? If the object shifts, how do I adjust instantly? These predictions require low-latency neural inference. Milliseconds matter. The faster the compute, the smoother the motion. Now here is the key insight. Gen 3 is not about adding more cameras. It is about improving how the neural networks interpret what the cameras see. True perception is not vision hardware. It is software intelligence. And if Tesla has successfully transferred lessons from autonomous driving into close-range manipulation, that is a massive breakthrough, because driving at highway speed is difficult. But cooking in a cluttered kitchen might be even harder. Vision is the foundation, but vision alone does not create intelligence. That comes from the neural network architecture itself, and that is where Gen 3 may become truly disruptive. The AI brain inside Gen 3 Vision allows a robot to see, but intelligence determines whether it understands. And this is where Gen 3 could be fundamentally different. Earlier versions of Optimus relied heavily on supervised training and teleoperation. Engineers controlled the robot remotely. The system recorded movements, then neural networks learned patterns from those demonstrations. That works for simple, repetitive tasks, but Gen 3 appears to go further. Leaks suggest a major upgrade to its neural network architecture. Let us break this down clearly. 1. End-to-end neural learning expansion Tesla already uses. End-to-end neural networks in its full self-driving stack. That means instead of manually coding every rule, the system learns from massive real-world data. If Gen 3 adopts a similar architecture, it could mean less rule-based programming, more real-world generalization. Better adaptation to unfamiliar environments. For example, instead of being programmed to pick up a cup, the network understands object properties and context. It recognizes shape, fragility, weight estimation, and required grip force dynamically. That is a major leap. 2. Multi-Modal AI integration. Gen 3 may integrate vision, motion, and language models into a unified neural stack. That means the robot does not just process images. It processes visual input, voice commands, spatial awareness. Task prediction. Simultaneously. For example, if you say, "Please clean the kitchen," the robot must understand the command linguistically, identify objects that require cleaning. Plan motion paths, avoid obstacles, adjust grip pressure. That requires coordinated neural layers, working together. Not isolated systems. 3. Faster onboard inference. Previous versions relied on powerful but limited onboard processors. Gen 3 is rumored to integrate an upgraded AI compute module derived from Tesla's vehicle hardware. Why does this matter? Because latency kills fluid motion. If a robot takes half a second to process sensory data, movements appear stiff and delayed. If it processes in milliseconds, it looks natural. Natural motion builds trust. And trust is critical for household deployment. 4. Self-improving through fleet learning. One of Tesla's biggest advantages is scale. If Optimus units share anonymized learning improvements, each deployed robot could improve the entire network. That is similar to how Tesla vehicles improve via over-the-air updates. This means Gen 3 may not just learn locally. It may learn collectively, and that changes everything because a robot that improves monthly through neural updates becomes more valuable over time. Not obsolete. Now, here is the critical insight. Intelligence is not about memorizing tasks. It is about generalization. If Gen 3 can truly transfer learning from one task to another, it becomes far more flexible, and flexibility is what separates a demonstration robot from a mass-market product. But intelligence alone is not enough. The body must execute what the brain decides, and that leads us to the next upgrade. Hands. Because without dexterity, even the smartest AI cannot cook, clean, or assemble. If you appreciate deep AI breakdowns explained clearly instead of just buzzwords, subscribe to the channel and turn on notifications. We focus on what is technically realistic. The hand problem. Has Tesla finally solved IT? You can give a robot the smartest brain in the world, but if its hands are clumsy, it is useless in a human environment, and this has always been the biggest challenge for humanoid robotics. Walking is impressive. Talking is interesting, but real value begins with hands. Gen 1 and Gen 2 Optimus models demonstrated basic grasping, holding a box, picking up lightweight objects, folding cloth with guidance, but fine manipulation remained limited. Gen 3 is rumored to introduce major upgrades in 3 critical areas. 1. Increased degrees of freedom. Human hands have more than 20 degrees of freedom. Each finger moves independently. Micro-adjustments happen constantly without conscious thought. Leaks suggest Gen 3 may significantly increase joint articulation per finger. More joints mean better grip angle control, more natural movement, improved object stabilization that allows the robot to crack an egg without crushing it, grip a wet plate securely, turn a doorknob smoothly. This is precision work, not factory repetition. 2. Advanced tactile sensors vision. Tells the robot what it sees. Touch tells the robot what it feels. Tesla is likely integrating higher resolution tactile sensors in the fingertips. Why does this matter? Because many objects behave differently than they appear. A tomato compresses, a glass slips, a sponge absorbs water and changes weight without pressure-sensitive feedback. The robot either drops objects or damages them. Gen 3 reportedly includes improved force sensing and possibly temperature detection. That allows dynamic grip adjustment, slip correction in milliseconds, safer interaction with fragile objects. This builds trust, and trust determines adoption. 3. Faster actuator response. Even with sensors, slow actuators create robotic, unnatural motion. Gen 3 may use lighter, more efficient microactuators that improves reaction time, energy efficiency, smoothness of motion. If movements appear fluid instead of mechanical, public perception changes dramatically because people judge humanoid robots emotionally. If motion looks unnatural, it feels unsafe. If motion looks smooth, it feels intelligent. Now, here is the deeper insight. Dexterity is not just about hands. It is about coordination between vision, neural networks, motion planning, to tactile, feedback. If Gen 3 truly integrates these systems seamlessly, it moves from demonstration robot to functional assistant. And that is a massive leap, because once the hand problem is solved, the range of possible tasks expands exponentially. Cooking, cleaning, tool usage, assembly, elder care assistance, all depend on precision, but even perfect hands and perfect vision are meaningless if the robot cannot operate efficiently for long periods, which brings us to the next critical piece. Power, because endurance determines whether this is a novelty or a workforce. Power system. Is Gen 3 finally practical? Intelligence is impressive, dexterity is powerful, but endurance decides whether Optimus is useful or just entertaining, because a robot that works for 2 hours and then shuts down is not a workforce solution. It is a demo. So what changed in Gen 3? Leaks suggest improvements in 3 critical power areas. 1. Battery architecture. Upgrade. Tesla already produces high-density battery cells for vehicles. Gen 3 is rumored to use a refined compact battery pack inspired by Tesla's latest cell design. This could mean higher energy density. Lower weight. Improved thermal stability. Why is that important? Because humanoid robots have a difficult trade. Off. More battery means longer runtime, but more battery also means more weight. More weight means more strain on actuators. More strain reduces efficiency. So Tesla must balance power and mobility carefully. Gen 3 reportedly reduces overall weight while increasing usable runtime. That is a major engineering achievement if accurate. 2. Improved energy efficiency through AI optimization. Here is something most people overlook. Smarter AI can reduce energy consumption. If motion planning becomes more efficient, the robot uses fewer unnecessary movements. If neural networks predict better, fewer corrections are required. If actuators are optimized for precision, less power is wasted. Gen 3 may combine hardware improvements with software efficiency gains that could extend real-world operational time significantly. Instead of short bursts of activity, the robot could sustain 8 to 10 hours of intermittent household tasks or multiple continuous factory shifts with scheduled charging. 3. Faster charging and thermal management. Battery performance is not just about runtime. It is about recharge cycles. Leaks suggest improvements in internal cooling systems and charging speed. That means shorter downtime between work cycles, better long-term battery health, reduced overheating risk. During intensive tasks, thermal stability is especially important for humanoid robots. Unlike cars, they operate indoors around humans. Excess heat must be carefully managed. Now, here is the key insight. If Gen 3 can reliably operate for a full day of light to moderate tasks with predictable recharge windows, it crosses a psychological barrier because practicality drives adoption. No business will deploy robots that constantly require downtime. Homeowner will trust a machine that dies mid-task. Endurance builds reliability, reliability builds trust, and trust builds market demand. But power, intelligence, and dexterity are not enough on their own. The final question is simple. Does Gen 3 finally move Optimus from prototype to scalable product? That is where we go next. Prototype. Oh, our product? So after analyzing the leaks? Upgraded. Vision system, more advanced neural networks, improved hand. Dexterity, higher efficiency battery architecture. Here is the real question. Is Tesla, but Gen 3 finally ready to move from demonstration to deployment? The honest answer is this. It is closer than ever, but it is not magic. Let us break this down clearly. If the vision upgrades are real, Optimus can perceive its environment more reliably. If the neural network architecture truly expands end-to-end learning, it can generalize better across tasks. If the hand improvements deliver human-like precision, practical usefulness expands dramatically. If runtime increases to reliable daily endurance, businesses can justify deployment. Taken together, these upgrades represent maturity. Tesla is not building a novelty gadget. It is building a scalable AI-powered labor platform. That is a massive ambition. But here is the important reality check. Humanoid. Robotics remains one of the hardest engineering challenges on Earth, even with advanced AI. Real-world environments are unpredictable. Objects move unexpectedly. Humans behave unpredictably. Edge cases are infinite. So Gen 3 will likely still improve over time, still rely on over-the-air updates, still face real-world limitations in early deployment. But here is why Gen 3 matters. It signals a transition from proof of concept to scalable intent. Previous versions proved possibility. Gen 3 appears focused on practicality, and practicality is what drives adoption. Now consider the long-term vision. If Optimus can assist in factories. Handle warehouse logistics. Support elder care, perform structured household tasks, then the addressable market becomes enormous. Not thousands of units. Millions. And if Tesla leverages fleet learning across deployed robots, improvements compound over time. That is the true power, not hardware alone. Network intelligence. So here is the final takeaway. Gen 3 is unlikely to be perfect, but it may be the first version that makes widespread deployment realistic. And once large-scale deployment begins, the pace of improvement accelerates dramatically. That is when disruption happens, not during keynote speeches, during iteration. If you want deep Tesla engineering analysis that cuts through hype and explains what is technically realistic, subscribe to the channel and turn on notifications. Comment below. Would you trust a Gen 3 Optimus robot inside your home today? Or would you wait 5 more years for a refinement? In the next video, we will break down whether Tesla can realistically price Optimus under $20,000 at scale, and what production volume would be required. That financial math changes everything, so stay tuned. Thank you for watching. Stay analytical. Stay realistic, and I will see you in the next one.